Today we are going to discuss what is this. What is this? This is a reference which refers to the current or invoking object. Now, in Java, when we create object, how do we create the object? We create a reference first and then we create object. So actually, reference refers to object, right? Object is stored in the heap and reference is stored in the stack. So what is this? This is something special in all the object-oriented programming languages. So this is a reference which refers to the current or invoking object. Okay, what is the importance of this? Why this is required in object-oriented programming languages? So when you create multiple objects, you have those many copies of instance members. When you create multiple objects, you have those many copies of instance members. However, you have only one copy of member function. That makes sense, right? So suppose if you create 10 objects of a class, so 10 copies of instance members are there in the memory, but only one copy of member function is there. In that case, how will member function keep a track of invoking object? How will member function keeps a track of invoking object? Who is invoking me? Suppose I am a member function and one of the objects is calling me. So how do I know which object is calling me? The answer is this. Member function or functions will come to know about invoking or current object through this reference. Okay, let's see this with the example. Okay, let's discuss this entire concept with the example. So we have got one example here. Public class student, private string name, private int age. As you know, these members, name and age, are instance members. Now, what do you mean by instance members? Instance members are those members which are allocated memory only after instance gets created. Then we have setter methods, which allow us to set name and age. You can see here set name, set age. Then we have getters, which allow us to read name and age, that is get name, get age. In these setter methods, I have mentioned this. So just wait for a moment. I will explain what is the meaning of this. So we have a class student and we have two instance members, string name and int age. And we have setters and getters for them. Now in the main function, somewhere in the main function, we are creating two objects of student S1 and student S2. Student S1 is equal to new student S2 is equal to new student. And then we call setter methods. S1 dot set name Rahul, S1 dot set age 23. That means first student's name is Rahul, his age is 23. Now second student S2 is equal to new student. So second student's name is Rima and her age is 21. And then we call getter methods to display their names and ages. Okay. Now here in this entire example, where is this or how can we discuss this? Okay. So let's go through the diagram here. We have So as per this code, there are two objects created, S1 and S2. So as we know, in Java, we have this side stack and this side heap. Okay. We are creating first object, student S1 is equal to new student in the example. Student S1 is equal to new student. So what happens? You know already. object of student will be created. Object of student or instance of student will be created at some address. And as soon as instance gets created, what happens? As soon as instance gets created, instance members are allocated memory. So that is name and age. And then S1. So what is S1? S1 is nothing but a reference on the stack, which refers to the object which is created in the heap. Okay. So S1 refers to that object. Then we have invoked setter methods, Rahul and 23. So in the name, what goes is Rahul. And in the age, 23. Then we are creating second object. Student S2 is equal to new student. So because of that, one more object gets created. Let's say that object is at 3000 address. One more object or instance of class student. Again, as soon as that object gets created, instance members are allocated memory, name and age. And then that object will be referred by S2 is another reference. Okay, and that reference will refer to this object. And then we have called setter methods in the code, Rima and 21. So Rima goes to name. And age is 21. Now here you can see that we have created two objects and there are two copies of name and age. Okay. So when you create multiple objects, you have those many copies of instance members. But what about member functions? What about member functions? Here we have four member functions: set name, set age, get name, get age. So whether one member function or multiple member functions, concept is same. So what is the concept? In order to discuss that concept, I will just write a block here for one of the functions. No need to write block for all the member functions. Okay. One of the member functions will clear our concept. Let us say set name. Okay. So this is the method set name. Assume that this is a function set name somewhere in the memory. Where exactly? That you will come to know when we discuss JVM architecture. At present, it is not important. So somewhere in the memory, set name has been allocated memory. Set name member function has been allocated memory, right? Okay. Now, let us come back to this concept. First of all, what is this? This is a reference which refers to the current or invoking object. What do you mean by invoking object? The object using which you are calling a function, that is called as invoking object. Now, what is the importance of this, which is more important than the definition of this? Okay, so when you create multiple objects, you have those many copies of instance members. However, you have only one copy of member functions. We can clearly see here, two objects are created, two copies of name and age, but only one copy of member function. Okay, what next? In that case, how will member function keep a track of invoking object? So that means in our code, in our code, we have called s1.setName. So this line says, how will setName comes to know that S1 has called it or S2 has called it. Okay. We as a programmer, we can clearly say, okay, S1.setName means S1 has called setName, or S2.setName means S2 has called setName. That's very simple. But for a function, suppose we are functions, and then how do we know that which object is calling us? That's the concept. Okay. So in that case, how will member function keep a track of invoking object? How will member function comes to know which is the invoking object, which object is calling it? So member function or functions will come to know about invoking or current object through this reference. How exactly? Let's see in the diagram. Suppose you have called s1.setName Rahul, right? s1.setName Rahul. So look at the diagram and just understand where S1 refers to. S1 refers to the object which is at 2000. Okay. So what do you mean by this line now? Member function or functions will come to know about invoking or current object through this reference. As soon as you say s1.setName Rahul, as soon as you say s1.setName Rahul, what happens? One reference gets created. One reference gets created. Reference is always stored on the stack. Okay, one reference gets stored in the stack, and that reference holds the address of S1. Now where S1 refers to 2000. So this reference will also store 2000. Okay. And then member function, that is setName, will somehow comes to know about the invoking object through this reference. Member function setName will comes to know about the invoking object through this reference. Then setName will say, oh, the object which is stored at 2000 is calling me. So I must serve the object which is stored at 2000. That means I must initialize the name of that object which is stored at 2000. Okay, so Rahul is initialized with this name. When you say s2.setName, now what will happen? The same reference now will store S2's address. Now where exactly S2 refers to? S2 refers to that object which is stored at 3000. So when you say s2.setName, I repeat, when you say s2.setName, the same reference now will hold 3000, and now setName will come to know that it has to serve that object which is stored at 3000. So it will serve this object, and what RIMA value you are passing, that RIMA value is initialized to name. Okay, so that's the way this is. That's the way this helps member functions to know about invoking object. Okay, so again, when you create multiple objects, you have those many copies of instance members. However, you have only one copy of member functions. In that case, how will member function keeps a track of invoking object? So answer is member function or functions will come to know about invoking or current object through this reference. Okay, just now we discussed whenever we say s1.setName, the reference gets stored. The reference stores the address of S1, that is 2000. When we say s2.setName, the same reference now stores the address of S2, that is 3000. And member functions are always in the member functions, always they come to know about invoking object through this special reference. So what is the name of this very, very special reference? The name of this reference is this. And this is the actual importance of this keyword or this reference. Okay. So in Java, whenever a question is asked, what is this? The answer is this is a reference to the invoking or current object. Immediately they will ask you, then what is the importance of this? Why this is required in object-oriented programming? So answer should be, when we create multiple objects, we have those many copies of member functions. Sorry, we have those many copies of instance members. We have those many copies of instance members. However, we have only one copy of member function or functions. In that case, how member functions come to know about the invoking object? The answer is this. Whenever we invoke any member function with the object, this reference stores the address of that object. And through this reference, member functions comes to know about the invoking object. Another point is how can we use this keyword in the program? Okay, can we use this keyword in the program? Yes. Now you look at my code. Look at my code, especially look at setter methods. How setter methods are written. Now in the class, I've got string name and age are instance members. And once again, in the setter method, set name and set age, I've got name and age. So question is, are these two variables, name and name, or these two variables, age and age, same or different? They are different. They are different. How come? These two are instance members, and these two, which are written in the method or member function, they are local members. They are local members. Now imagine in this code, I know as a programmer that this name is instance member and this name is a local member. And what's the logic here? When we call set name Rahul, that Rahul will come to the local member. And somehow we have to initialize this instance member using this local member. So as a programmer, I know very well that if I say name is equal to name, this name is instance member. That's my understanding. This name is instance member and this name is a local member. That's my understanding. But that will not work. That will not work. If you write name is equal to name, what will happen is compiler will give preference to local member. So between instance member and local member gets more preference or precedence. So what will happen is when you call s1.setName Rahul will go to this local member and then the local member will initialize itself only. Nothing will go to instance member. Okay, so that should not happen. That's why you must inform compiler that this left-hand side argument is instance member and right-hand side argument is a local member. How will you inform that? Using this. Now, when you write this dot name, that means compiler understands that this particular member is instance member and this particular member is a local member. Okay, this particular member is a instance member and this particular member is a local member. Okay. Now, you might say, why local member name is name? Just keep it XYZ. Won't it work? In that case, what will happen is we don't have to write this dot name is equal to name. We can simply write name is equal to XYZ. Okay, so now there is no confusion. Okay, XYZ is a local member and name is an instance member. It's a very straightforward case. Name is equal to XYZ. That means name will be initialized with XYZ. But this will work. No doubt about that. This will work. But this is against the convention. And in Java, you must follow convention. Industry follows convention. So even though this is correct, this will work, no doubt about that. You are not supposed to write like this. You are supposed to write always like this in the setter method. In fact, you are going to use Eclipse or some other IDs. They automatically generate setters and getters for you. And when they generate setters and getters, they follow naming convention. Okay, so this is the way this keyword is used in the code. Okay, now before I conclude this topic, uh, one thing I would like to tell you, all of you, whenever in the interview question is asked, what is this? People answer that this is the reference to the current or invoking object. Okay, right. And when the question is asked, then what is the importance of this? They explain this particular concept, that this is used to resolve the confusion between instance member name and local member name. No, don't say that. Even though that is correct, but that is the secondary use of this. The main concept is this, which we discussed here. This refers to the invoking object, and with the help of this reference, member functions come to know that which object is calling them, and they serve that object accordingly. So this is the main concept of this reference. Okay, thank you.